Have you ever wondered how this infinite universe came into existence? How billions of stars were born? Or what mysterious force drives everything we see around us? These are some of the most profound questions humanity has ever asked. While many theories attempt to explain the origins of the universe, one stands out as the most widely accepted and debated: the Big Bang Theory. What is the Big Bang Theory? Approximately 13.8 billion years ago, there were no stars, no planets, no galaxies, not even time or space. It's hard to imagine, but everything was nothing. Then, out of this nothingness, a single point smaller than an atom appeared. This point contained an incomprehensible amount of energy and was at a temperature of trillions of degrees. This leads us to an important question. How did this point arise from nothingness? Unfortunately, science cannot yet answer this. The Big Bang Theory explains what happened after this point existed, but not what caused it to appear. Religious beliefs often suggest that a divine creator or God brought the universe into existence. Science counters by asking, if a point cannot form from nothingness, how did God come to exist? Both perspectives have unanswered questions, but what we can do is explore the evidence-based journey that started from this mysterious point. The expansion of the universe. The term Big Bang might sound like a massive explosion, but it wasn't. Instead, that tiny, unimaginably dense point began to expand in all directions, much like how a balloon inflates when you blow into it. In the very first moments of this expansion, space and time were born. This means there was no before the Big Bang, because time itself did not exist. The universe began expanding faster than the speed of light, and in this rapidly growing cosmos, only pure energy existed. How energy became matter. Here's where it gets fascinating. According to Einstein's famous equation, stirred E equals mc squared, energy and matter are interchangeable. Energy can transform into matter, and matter can become energy. Let's break it down. Imagine a bomb exploding. Matter from the bomb is converted into energy. During the Big Bang, this process worked in reverse. Energy transformed into tiny particles of matter. However, there's a twist. Along with matter, the Big Bang also created its opposite, antimatter. When matter and antimatter meet, they annihilate each other, converting back into energy. So how did anything survive? Luckily, there was a tiny imbalance. For every billion antimatter particles, there were 1 billion and 1 matter particles. This small excess of matter is what formed all the stars, planets, and galaxies in the universe. Without this imbalance, nothing would exist. Formation of the first atoms. As the universe continued to expand, it began to cool. Within fractions of a second, subatomic particles like protons, neutrons, and electrons formed. These particles combined to create the first atoms, primarily hydrogen and helium, the simplest elements in the periodic table. For the next 380,000 years, the universe was filled with a dense cloud of these elements. Slowly, gravity pulled the atoms together into massive clumps. These clumps ignited under immense pressure and heat, giving birth to the first stars. The birth of stars and elements. Inside these stars, nuclear fusion occurred, creating heavier elements like carbon, oxygen, and magnesium, the building blocks of life. But elements like gold, platinum, and uranium required even more energy to form. When massive stars reached the end of their lives, they exploded in spectacular supernovae. These explosions released the energy needed to create the heaviest elements in the periodic table. The oxygen you breathe, the calcium in your bones, and the iron in your blood were all forged in ancient stars and scattered across the cosmos by these supernova explosions. Galaxies and the structure of the universe. As time went on, these heavy elements, along with dust and gas, began to coalesce under gravity, forming galaxies. Our galaxy, the Milky Way, is just one of billions in the universe. It contains over 300 billion stars, including our Sun. Each galaxy holds billions of stars, and each star system has the potential to form planets. This cosmic recycling of elements is what makes life as we know it possible. Evidence supporting the Big Bang Theory. The Big Bang Theory is supported by strong evidence. 1. Galactic expansion. In 1929, astronomer Edwin Hubble observed that galaxies are moving away from each other. This suggests that the universe is still expanding and must have started from a single point. 2. Cosmic microwave background, CMB radiation. In 1964, scientists Arno Penzias and Robert Wilson discovered faint microwave radiation permeating the universe. This radiation is the afterglow of the Big Bang and serves as a snapshot of the universe's early moments. 3. Elemental abundance. The proportions of hydrogen, helium, and other elements in the universe match predictions made by the Big Bang Theory. 4. Modern observations. Telescopes like NASA's WMAP and the European Space Agency's Planck spacecraft continue to capture data that aligns with the Big Bang Theory. The universe's current state. Today, the universe is 13.8 billion years old and spans over 93 billion light-years in diameter. It is still expanding, and galaxies are moving farther apart. The temperature of the universe has cooled to approximately minus 455 degrees. Somewhere in the vastness of space, stars are still forming, galaxies are colliding, and supernovae are exploding, continuing the cycle of creation and destruction that began with the Big Bang. What's next? The universe's journey is far from over. Scientists continue to study its expansion and debate its ultimate fate. Will it keep expanding forever? Or will it collapse back into itself in a big crunch? These are questions we'll explore in future videos as we continue the journey of the universe. From a point smaller than an atom to the vast cosmos filled with billions of galaxies, the story of the universe is nothing short of extraordinary. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe to our channel and hit the bell icon to stay updated on this incredible series. Stay tuned for the next episode of The Journey of the Universe, where we'll dive deeper into the formation of galaxies, our solar system, and the origins of life.